Hi everyone. Today you'll see the title up at the top of the screen. What we're going to go through is sketching parabolas. Now, this is very similar to us doing our quadratic equation review. We make the assumption that you were very good at solving quadratic equations. It was really about getting better. Same thing for today. I make the assumption that everyone in here can sketch a parabola. First off, it's grade 10 material. But secondly, we've already reviewed this way back in Unit 1, or covered it, us going through and sketching it based on transformations. Today what we're going to look at is we're going to look at sketching parabolas, and not just how can we sketch parabolas, we're going to get over that pretty quick, but rather how can we get better at sketching parabolas. So what we're going to do is we're going to examine multiple ways to go through and sketch a parabola, but also we're going to look at some of the theory behind it. So there may be a few new things that we talk about today, some things that you haven't really put a focus to in the past, but also it's going to be about options for how we go through and we sketch, and maybe there's going to be a little decision making as to which methods you like to try in a given situation. So let's start off with the one that we see on our screen. This is a really straightforward parabola. As I said, we should all be able to go through and sketch this. The first thing that I want to make sure we're good with is that we have to have the most important point on our parabola labeled at all times. We need the change of direction, we need the vertex. So when you take a look at that equation that's been given, you notice it's written in vertex form, so we can just read our vertex from it. We can see our vertex at 3, -4. For us now, what we need is we need 2 other points. And if we are going to sketch our parabola, then preferably, we would like those points to be on opposite sides of the vertex just to give us an idea of shape. They don't have to be. As we said, like way back in Unit 1, we sketched based on transformations. But if possible, we would like those 2 points to be on opposite sides. So what we need are 3 points labeled, same as normal. Most important point, vertex. So right now I know that I have my vertex, but I'm missing 2 other points. The easiest thing to do, I would imagine, would be just to find another point. And what we're going to do is we're going to find a special point. Like we're going to go through and we're going to find our y-intercept. If this was an application question, quite often your y-intercept acts as like a starting value or an initial value. So let's go through and find it. We know we can always do that by subbing in x = 0. That is going to give me 2 times my -3 squared. There's my 9. And if I do my calculation, there's my 18 - 4, 14. So all I'm going to do is put on what I have on the screen right now. I need to have a y-intercept up here at 14, so that's going to be pretty high. I also need my vertex to be at 3, -4. And so maybe I'm over a bit and down, and maybe I estimate that that's about 3, -4. I can see that my parabola is opening up, so I'm going to label my vertex below that point. Okay, I have 2 points, and all I want to remind us of is just that key property and very important property about parabolas, the fact that they are symmetrical. So we recall we have our axis of symmetry, that is that vertical line that makes one side of the parabola symmetrical to the other. That as soon as I found that point of 14, I actually also found its matching point that would be reflected across the axis of symmetry. I know that it has to be equidistant on the other side. That's what reminds me it's reflected. And so if I notice that that y-intercept is 3 units to the left of the vertex, then its matching point, coordinating point, needs to be 3 units on the other side. We should be able to now label that point at 6, 14. Okay, I'm just going to get rid of all of that green because that green should not be a part of my sketch. And maybe that's the best I can do in quick circumstances. And now all I need to do is connect my 3 points with a smooth curve, the best I can. Arrows on the end to show that it goes up in that direction forever and ever, and there's my parabola. So I think for most of us, that is probably the most straightforward way that we can sketch. And that is a method that I would have in my back pocket. If I'm given my equation in vertex form, if I can find my vertex, use my y-intercept, and then reflect my y-intercept, in most cases, those are going to be the 3 easiest points that I can deal with. Okay, what I would also like to do, though, is just to go through, and I would like to sketch this using different information. Again, this is about us getting better. So we should have the red in our back pocket. Okay, well, what else could we do? Well, I think we're still going to use the red aspect of finding the vertex. That is way too easy to not use in that circumstance. I can read it from there. I'm not going to try to find the vertex a different way. Maybe what I like, though, is since I want points across from each other, like I just found, then maybe one of the other easiest things is to find those points that are across from each other. That is, those special points, those x-intercepts. So what I might do is I might choose to find both my points at the same time. So to find an x-intercept, I'm going to sub in y equals 0. Now that's going to give me this equation, and I just want to work a little bit on maybe where our instinct takes us. I'm going to have a bunch of people right now that in order to solve that equation, they're going to want to expand those brackets and collect like terms. And I am going to put a huge warning or a big question of why would you want to do that in that instance? Recall that for us to go through and solve an equation, the first thing we always should look to do is to isolate our variable. And notice your variable is in one spot right now. That means you can isolate it. Just make a note that if you did go through and expand those brackets, now you're putting your x's in 2 spots. That forces you to have to go through and look to try to factor it or look to use quadratic formula. When if I look at my purple equation, isolating is going to be more efficient. So fight the urge to I see brackets, I expand reflex. And instead, if we see our variable in one spot, let's isolate it. So let's get rid of the 4 and let's try to get just the variable term all by itself. Okay, now I've got that coefficient of 2. I can divide that out. I'm still working. There is my variable term all by itself. I had the 2 times. Now I've divided out that 2. Now I'm trying to isolate for just the variable. The next part I can do is I can get rid of that squared. And in order to get rid of that squared, I can take my square root. Just remember that every time you choose to take a square root, we have 2 possible answers, our positive and our negative. Well, to finish off isolating, all I need to do is get rid of that minus 3, and I'm going to add 3. Now, I just want to draw your attention to why we wouldn't write it in that form. Notice, if I write it kind of sloppily, then there could be some indecision as to whether that 3 is under the root or outside of the root. When I hope that we can tell, it should be outside the root. And so our general form in that case is going to be to put that 3 out in front of the plus or minus. Now there is no ambiguity over is that 3 underneath or not? No, it's clearly not. Okay, what we just found was our 2 x-intercepts. And so we notice that one of them to the right would be our 3 plus root 2, and the x-intercept to the left would be our 3 minus root 2. Notice you could take those 2 points, and I'm just going to circle the vertex to kind of almost put it in purple now. that with those 3 purple points, you would have your parabola sketched. I think those are your 2 best methods in this instance to be able to go through. But in order to have a better sense of what we just did, I'd like us to get down something from our background. And then really what I want to do is I want to break it down a little bit more to see if we can examine something a little bit better to have a better sense of what something actually means from our past. Okay, I know that that sounds really, really cryptic, especially when I word it that way. But I'm just going to make a little extra room. And off to the right, I'm just going to jot down my good old quadratic formula. I would like you to get down your quadratic formula. Because in that quadratic formula, what I'm going to do is I'm going to actually break apart my fraction. Right? On top, I have this plus or minus. So that means that I have 2 terms. So what I'm going to do is I'm going to break apart and instead write my negative b over 2a, then my plus or minus. Sorry, that's a really sloppy plus or minus. Plus or minus my root b squared minus 4ac over 2a. Now, I'd like you to just take a look at that for a second and notice that that final blue line, if I did simplify it, they have a common denominator, I would put them together, would give me my original quadratic formula. You might ask, okay, why are you bothering to separate it? But I do just want to draw your attention to something very important in this instance. And it might be, or probably is, something that you haven't really considered. We've reviewed how to find the vertex. And we found that you could find the vertex because you know the x-coordinate of your vertex is always negative b over 2a. Notice, that's your first fraction. That is the x-coordinate of your vertex. What you then see with your plus or minus, what that is the distance from, and I'm just going to put AOS for your axis of symmetry. That might be something that you have never considered before in your past, even though you've worked with quadratic formula for a full year. That when we actually break down quadratic formula, it also gives me some other information if I want to think about my quadratic function graphically. Negative b over 2a gives me the x-coordinate of my vertex. That second fraction, the square root of b squared minus 4ac all over 2a, actually tells me how far away from the axis of symmetry my x-intercepts are. So if we can go back to the picture of our parabola, what I'm going to do is just make this a little bit bigger. In that last instance, when we see our purple x-intercepts of 3 plus or minus root 2, what that actually tells me is my axis of symmetry, and that is a horrible looking axis of symmetry. I'm going to grab my straight edge to make sure that I can do this as best as possible. My axis of symmetry would be at x equals 3. You can see 3 at your vertex. What that actually tells us is to get our x-intercepts, we are root 2 away from the axis of symmetry. And if, and I'm just going to shrink this back down again, you were to go through and take that purple equation and expand your brackets, collect like terms, and now solve that using quadratic formula, what you're going to find is that root b squared minus 4ac all over 2a would equal root 2. So it's something a little bit different and something that I don't think we often give a lot of thought to when we first get introduced to it. You get introduced to quadratic formula and hey, you're just trying to make sure that you're comfortable using it. For some of us, we're maybe just trying to remember it. Now that we've had some experience with it, now's our job to get better with it. That maybe that might be something that you can use and have in your back pocket when we need to go through some problem solving. Okay, let's jump into some more, and really all we're going to do is just keep ironing out different ways that we can sketch. So let's take a look at the parabola that's been given. There's your function. You can see it's a parabola because you've got your squared. We need to now go through and we need to sketch it. So what I would like to do is I would like you to just get going right away. So I think you should be able to put down a sketch for that parabola with very little difficulty. Okay, go ahead and give it a shot. Pause the video now. Okay, we're back. So first thing I notice, it is in vertex form. So I know that my vertex is at -1, 4. I also notice that my parabola is opening down. So my suggestion to you would be to do this. Plot your point at -1, 4. So maybe I'm up here somewhere. Since it's opening down because of that -a value, I'm going to label my vertex up above. Okay, now that I've got that, I need 2 other points. And I think the easiest thing to do is to let's find our y-intercept, so we're going to sub in x equals 0. So that means I've got my y equals -2/3 times 1 squared plus 4. Okay, so that's going to give me a -2/3 add on 4. So I need my common denominator. That's going to be thirds. That means I have a -2 of them, add on 12 of them. I get down to 10 thirds. Okay, that tells me then that I have a y-intercept at 10 thirds. So I now need to reflect that across so that I have a matching point on the opposite side. And now I need to label the coordinates. So if I caught up to you and you happen to make a mistake, then what I want you to do is pause the video and come up with the coordinates of that other point. Pause it now. Okay, or we're still on the right track and we're still going. So if I have that, then I know that my point is 1 unit to the right. Therefore, we should be 1 unit to the left to get that other point. So 1 unit to the left from my vertex puts me at an x-coordinate of -2. And since I'm going horizontal, I have to have the same y-coordinate. Okay, connect everything, and we should be good. So smooth curve, making sure that we would pass the vertical line test. Yikes, I don't like that other side. Passing through those points. Something like that. And there we go. Okay, I'm going to just put up an alternate solution for anyone who chose to find x-intercepts. So we take a look, and maybe we said to find x-intercepts, we're going to allow y to equal 0. So I've got my 0 equals -2/3, x plus 1 squared plus 4. Okay, to work my way through on this one, I got to get rid of that +4, so I have a -4. Now I have to get rid of that coefficient of -2/3, which means I am going to multiply out my 3 and divide out my -2. So the negative divided by the negative is going to give me a positive value. 4 times 3 is 12, divided by 2 is 6. Now to get rid of the squared, I take the square root. And I know when I take the square root, I get 2 answers. And we're good on our form to put that -1 on the outside to avoid any confusion. So I could see having this parabola with my blue vertex labeled and also my x-intercepts in green And there we go. So you're not going to give me all 5 points. You're going to give me 3. So you're either giving me the blue and the red or the blue and the green, and I think we are good. Okay, we're going to just keep it going. Let's take a look at the next one. So what I'd like you to do is just take a look at the equation I've given you this time, and you'll notice that I've changed something on you. That the previous 2 problems we went through, and I gave you your equation in vertex form. This time I've given you your equation in standard form. I'd like to walk through this one together. Again, I don't think it's difficult. We should all be fine with it. It might require a little bit of review, a little to just fine tune, but I also want to make sure that we have multiple options. So, I would argue to you that this is like us tackling the last problem when we were changing our parabolas to vertex form. You notice that your equation is in standard form. You can't read your vertex from it, but you know you need your vertex to sketch your parabola. So probably the first thing we're going to do then is go on the hunt to find the vertex. So how do we find our vertex? Well, 4, and I notice that I have a negative out in front, so my parabola is opening down. That means I have a max. So for my max, I know that my x value of my vertex must be negative b over 2a. So I'm going to go ahead and do that. So I know that my x-coordinate has to be -7 over 2 times -1. And that gives me my x-coordinate of 7/2. Okay, now that I have my x-coordinate of 7/2, I know that I can find any y-coordinate by subbing in my x-coordinate. So I'm going to sub x equals 7/2 back into my original. Now, you may write this down and say, okay, so that's going to be a negative 7/2 squared plus 7 times 7/2. But as we discussed previously, I think the best thing for you to do is to simplify each term. I'm just going to warn you. Watch out for misinterpreting me subbing in 7/2 as 7/2 squared and negative versus negative 7/2 squared. I want us to look back up into the equation on the screen and notice the big difference between what was given, what I circled in red, and what I wrote in blue. Let's make sure that we follow our BEDMAS, square our x value, then make it negative, and that we don't confuse that with the blue. So I'm going to erase all of that because I like this as your first line. So let's square our 7/2, make it negative. So square 7, square 2, make it negative. Then I can go ahead and multiply 7 times 7/2 and multiply my 5, subtract my 5. So I have a little bit of a confirmation there that my middle term is double the first, or the first term is half the middle. Or when I now get my common denominator of fourths, I get my full confirmation. Easier to see there. The middle term and first term are opposite signs. Second term is double the first is half the second. Okay, I go through and I simplify that. Negative 49 plus 98. Well, there's a positive 49. Oops. I did notice I just went and got a common denominator with -5, but I didn't change that to get that value. So I got to have my minus 20. Now I like that, and so that's going to get us down to a 29/4. So I just found then that my vertex was at 7/2, 29/4. Okay, that was my most important point and a point that I needed to have labeled. If I were you right now, this is what I would do. Plot your vertex at 7/2, 29/4. So we're good that that is like 3 and a bit. I don't even care that it's 3.5. It's 3 and a bit. And then 29/4, well, if I take 29 and I divide it by 4, that's going to give me like 7 point something. So I don't even care that it's 7.25. It's 7 point something. So I'm going to have my vertex at 3, 7, right? Over a bit, up a bit. My parabola is opening down, so I'm going to label above. Yikes, I was just about to write down my decimal. 7/2, 29/4. Okay. Now, I know that I need 2 other points. And before I blindly just go, oh, okay, so now to find the y-intercept, I'm going to sub in x equals 0, just like we did before. Stop. Remember what one of your benefits was to having your equation written in standard form. You can see your y-intercept. It's written right there. So we don't have to do any work to find it. I know that my y-intercept is at -5. So maybe somewhere down there. Okay, well, we can reflect that point across now. If what I have here, my y-intercept would be 7/2 units away from my vertex, which means I need to be 7/2 units on the other side. Well, if I double 7/2, then my halves are gone. If I take 7/2 and I double it, I get out to 7. So I know the location of that other point. It would be at 7, -5. Okay, I can delete out all that black because we don't need that. It should not be a part of our parabola. But now I can go through smooth curve and doing your best to draw it symmetrical, and there we go. So notice the fact that we were given our equation in standard form meant we had to take a different strategy to get there. But I think it should have been pretty straightforward. Pretty much a review problem from last time. Okay, I'm going to put a little wavy line in there because maybe we tackled that a different way. And so what I'm going to do is I'm going to actually make the focus be 2 points first. There's nothing that said we had to find the vertex first. We just know we have to find it. What if our goal was to find the x-intercepts first? That means we're going to sub in y equals 0. We're going to find the 2 points across from each other first. Well, the first thing I hope that we would notice is we've got a negative leading coefficient. And probably the time it would take to take a peek and see does that factor or use quadratic formula. My recommendation to you would be divide everything by that -1 and change all the signs. Now we have a positive leading coefficient. We probably can tell whether it can factor faster in those situations, but also in quadratic formula, we're going to make sure that we don't make silly sign mistakes. So what I'm going to do is just draw to your attention very, very quickly what may happen if you chose to use quadratic formula with the negative leading coefficient. Okay, we would say therefore x equals, and I'm going to go fast here, -7 plus or minus the square root of 49 minus 4 times -1 is a positive 4 times -5 minus 20 all over -2. And maybe we simplify it down to this. We have a major problem here. My denominator is negative, and that is horrible form. I can tell that that doesn't simplify in any other way. That is, we can't simplify our root. We can't divide out a common factor in that regard. So we may be tempted to leave it in that form. That is not good form because of the negative on the denominator. So notice, by leaving in your negative a value, you're almost setting yourself up to have to adjust that equation. You would have to divide out a -1 from all of your terms, change that to a +7. When you divide out a -1 from a plus or minus, it just makes the plus become a minus and the minus become a plus, so it appears like there's no change. There's our solution. It's work that's not needed. So, my argument to you is, then why do it? Instead, change the signs of everything. Now you have a positive leading coefficient. It helps you to factor, but also you don't then have to deal with any sort of a sign issue as you go. There we go. Okay, for anybody who wanted to find the blue first, I just want you to notice, you found this, 7 plus root 29 halves. And now what we have is this, which is 7 minus root 29 halves. Okay, with what we talked about on the previous problem, I am hoping that we can maybe see there is your vertex, or at least the x-coordinate of your vertex. And so if you choose to use quadratic formula first, that's not necessarily a bad thing. I'm not saying it's a better thing. I'm just saying it's not a bad thing. You now know that you have an x-coordinate of your vertex at 7 halves. That you could now begin the process of going sub x equals 7 halves back in, because now you're going to find the y-coordinate, and I want you to notice you're still going to have to do the red. So, in terms of big strategies, how can you work your way through? Well, you can find the vertex since it's the most important point first, which means you're taking the root of the purple. To finish off the problem, you deal with the red. Now it requires the green. So now you need to take your y-intercept, which we can read, but it requires a little bit of work to reflect it to find the third point. Maybe instead you deal with the blue first. The blue gives you 2 points, and it gives you half of your vertex. And so then all you have to do is finish off with the red. I don't necessarily know which one's more efficient. They're almost equal in terms of work, I think. By the time you take the purple with the red with the green versus the blue with the red, I don't know, I think it's pretty equivalent. My pressure to you would be get comfortable with both. Clearly, the most important thing is make sure that you can sketch a parabola using one of those methods. But my pressure to you is we should be flexible enough to be able to deal with both. Okay, we're going to pick up the pace a little bit, and we're going to tackle 2 more. Here we go. Okay, I want you to take a look at the function that I've given you in D. We can tell it's our parabola because we got our squared as our highest degree. Here's where I'm going to challenge you in terms of your process. And maybe what it requires is you having a sense of where your strengths and weaknesses are. That if I take a look at D, one of my ways that might be fastest is to find my x-intercepts first. Let's make sure that we don't automatically make our default sub x equals negative b over 2a in for every problem. It shows a lack of flexibility. That means you have one method only, and if anything got in the way of that one method, we're going to almost be out of luck. So what I want to walk through is a different way to go through and sketch that parabola, and one that would have us finding x-intercepts first. So to me, to find my x-intercepts means my y value is 0. That is going to give me 0 equals, and maybe before I start just blindly copying that out, I might take a peek and say, if I have to solve a quadratic equation, I have 2 choices, factor or formula. And since the equation was given to me in standard form, it might be worthwhile for me to check and see, does it factor? Depending on our comfort level with factoring, if you can factor in 10 to 15 seconds, Then to consider, okay, two numbers to multiply to give 2. There's a 6 and a 4. I can't get a 5 from that. But an 8 and a 3 I can. Hey, wait a second, that thing factors. And now, to go ahead and factor it, it might be worthwhile for you to look at that. Now, if factoring a complex trinomial is taking you 30, 40 seconds to deal with, then I don't know whether I would spend the time doing that. That's telling you we need extra practice on our factoring. But if we're pretty solid with that, then we can come away with x equaling 3/2 or -4 as our two x-intercepts pretty quickly. In fact, I could go ahead right now and say, okay, so like 3/2 is 1.5. Maybe that would put -4 down here. Maybe that's somewhat proportional. I now have, I'm also, don't like where I just labeled that -4. I'm almost certain to put my parabola through it. There I have my 2 points. Well, now all I need is my vertex. So some people would go, so now you would go for your minimum x equals, no, I wouldn't use my x equals -b over 2a right now either. I understand that for some of us, yes, we can go that route, but I want to show us a different route. Instead, what I'm going to do is I'm going to focus in, on my axis of symmetry. I know that I have that dotted line that's going to run directly down the middle. Wherever the heck the middle of that parabola is, I know that my axis of symmetry has to run down there somewhere. So what I'm going to do is I'm going to go on the hunt to find that axis of symmetry. I'm solving for a vertical line, so it's an x equals something. And I know that my axis of symmetry has to be exactly in the middle of my two x-intercepts. So I'm just going to get rid of that visual because I know that to find the middle of two things, I can just take its average. So I'm going to take one of those x-intercepts, add it to the other one, and divide by 2. I know to find an average, between two things, you always do is just add them together, divide by 2. So on top, I can get my common denominator. That's going to be a -8 plus 3/2 all over 2. That means I have a -5/2 divided by 2. That's a -5/4. And that's reasonable. To be right in the middle of -4 and 1.5, I'm going to be like -1.25. Okay, now that I have the middle, I'm going to go through and I'm going to sub that middle, that x value of -5/4, back into my original. So what I'd like you to do is to finish that one off. Let's just get a little extra simplifying fractions problem experience and make sure that we match up in the end. So go ahead and find your y coordinate, pause it now. Okay, we're back. So I'm going to take that y equals, and I'm going to go through, and I'm going to calculate each power, square it, top and bottom. Now I can go through and multiply my 5 times my -5, and I have my -12. Okay, before I just blindly get common denominators of 16ths, I can see that that 2 is going to cross-reduce. I can divide out that, which means at the very least, my common denominator can be 8ths. So that means I don't even have to change the first fraction, which is nice, 25/8. I need to double the second one. There's my confirmation again. And now my -12 as 8ths is -96. Okay, I put that stuff together. I'm going to get a -25 minus 96. That's going to get me down to a -121/8. Okay, what I just found then is that my vertex would have to be -1 and a bit and down, well, 121/8. That's going to be like -15 and a bit, way down here at the bottom. And something like this. And there we go. Now, I do have a little confirmation. Remember, I can see my y-intercept. So I have a little bit of a check. So if I wanted to go through and say, okay, well, what was 121 divided by 8? Well, that's going to give me like about 15 and a bit. So negative 15 and a bit. So it makes sense that I would have like my negative 12 somewhere up here. Remember, I'm not going to put it on, but it just helps me for a little confirmation. I do have a parabola that is opening up. The only thing left to do now is connect everything with a smooth curve. I'm coming through the 1x-intercept, smooth curve as best as I can. Arrows on the end, and we are good. So, something that maybe we wouldn't use instinctually, but something that can be very helpful. Using the axis of symmetry in order to find our vertex. Okay, I think you've got everything you need at your disposal. Let's finish off with one. You go as fast as you can. Okay, problem E, I want you to go as fast as you can. Let's go ahead and produce a sketch. Pause it now. Okay, we're back. So, maybe we went through and we said x-intercepts. Because we can look at that and say, hey, I know that thing factors really quickly. And therefore, I get x equals 4 or negative 2. I could then say that my axis of symmetry has to be right in the middle. So it's 4 minus 2 over 2. That's a 1. And now I could sub x equals 1 back into the original, and I get 1 minus 2 minus 8. There's a negative 9. I now have everything that I need. Okay, written down really quickly. Or maybe what we did is we said, for our minimum value, we know x has to equal negative b over 2a. So that's going to be 2 over 2, x equals 1. We can now sub x equals 1. You don't need me to do that, but I'm going to. Y equals negative 9, and we get our vertex. Then we use our y-intercept of negative 8 up in the original problem. And we could now reflect that across. Reflect it 1 unit on the other side puts me at 2, negative 8. I would have expected to see either the blue or the red on your page. In either case, we should be getting this. 1, negative 9 puts you down here somewhere. Perhaps you have the red at negative 8, which means you reflected that to 2, negative 8. Or you had the blue, which puts you at negative 2 and 4. I don't know what you have, but you should all have the purple and either the red or the blue, and there we go. Nice. Okay, your job is to try to be really comfortable with sketching a parabola. As I said at the beginning today, it shouldn't be an issue of can we create a sketch. It should be an issue of how flexible are we with it? Do we have options at stuff? Do we understand our parabola a little bit better? So my challenge to you might be, try to be flexible with your practice today. Jump in and sketch a parabola, but don't just sketch one using the same form all the time, same process all the time. Try different things. You know, if the equation looks a certain way, tackle a different method. If you see it in vertex form, then play around with it in vertex. But sometimes use the x-intercepts. Don't just use a y-intercept and reflect. If it's in standard form, then maybe try to find x-intercepts first and use the axis of symmetry. Or maybe you use negative b over 2a to find the vertex first and then reflect. Your options. But try to be as flexible as you can with your practice. Okay, best of luck with everything.